Hello all. We're going to be trying to find this limit using sequences today. And we're going to see that it doesn't really work in the way we want it to. And this should tell us that sequences are not necessarily going to be the way we want to deal with limits going forward. So let's go ahead and take a look at this. We've got the limit of x squared plus 1 all over the square root of x as x approaches 3. Now we want to know where this function is going to go, where the y values of this function go as the x values approach 3. So a couple of questions to answer here. How do we find an exact answer to this? And if we can't find an exact answer, can we make a good guess? Because that would be pretty good anyway. So let's go ahead and give this a try. We need some kind of calculator or some such to put the numbers into. I'm going to use Desmos. You'll see already I have the function put into Desmos, and I have a table set up for us. In this table I can put in any x value I want, and the y values this table is going to give me the y values from the function. So we need a collection of x values that are approaching 3. And so let's go ahead and say we'll pick 2.9, 2.99, 2.999, and so on. And what we're going to be doing is we're going to be taking a look at how these numbers are changing as we get closer and closer to 3 with these x values. So as these x values get closer to 3, the y values are going to shift a little bit, and they are hopefully going to converge on something that we are going to be able to recognize. So we'd start with 5.5 dot dot dot, and as we keep going, some of these decimal places seem to be staying the same. And so by the fourth entry here, we're probably relatively confident that the 5.77 is probably correct. Maybe even that 3 is correct, we can't be sure. And we can just keep going until all of those decimal places that we can see are correct. But this doesn't seem to be heading anywhere exact, and so the best I'm going to be able to do, I may not find an exact answer here, I'm just going to find a good guess. And that's okay, but we'd like to get the exact answer if we can. And so let's go ahead and try something. Maybe we'll try to approach 3 from the other direction. So we'll start with 3.1, 3.01, and just keep going. Okay, so we tried to approach 3 from the other direction. It does look like it's approaching 5.773, looks pretty likely, and then something after that. And so this isn't approaching anything we recognize, which is kind of a difficulty for us. We don't really know the exact answer to this, and we can find many, many, many decimal places, and if it's not heading anywhere that we recognize, we will not be able to give an exact answer. It turns out that this is headed towards 10 divided by the square root of 3, which is this decimal approximation right here. Of course, this is only accurate out to the end, out to that last 9. But the difficulty here is that even looking at these decimal approximations, we would never guess that the actual answer is 10 over square root of 3. That's not a normal decimal approximation that we are going to recognize. And that's going to be true of most of these limits. Most of these limits are not going to head to some location that we are going to immediately recognize as a decimal approximation of something. And this limits our ability to do these problems with the accuracy that we want. So we'll talk a little bit more about how to get past this in future videos. But for now, thanks for watching and happy mathing.